All right, I'm Jake Jensen. I'm the Associate Vice President for Research at the University of Utah. And I want to thank all of you for being here tonight for this wonderful event. We are at such an amazing moment in critical minerals and strategic materials research, both here at the U, but also at Rio Tinto, and really globally, right? A really key pivot point where I think a lot of exciting things can happen. And so tonight we're going to have a conversation with two stars. You are so lucky to get these two tonight. I have the pleasure of introducing both of them, and I will do so. And then I'll kick us off with a little bit of questions, but I want you to be thinking about what sort of questions you want to ask, because this is a forum for you to ask your questions. I'm just trying to get the ball rolling a little bit. First, let me introduce Mike Free. Mike Free is a professor in the Department of Materials Science and Engineering at the University of Utah. He has performed research and taught courses as a faculty member for more than 28 years. His areas of expertise include hydrometallurgy, electrometallurgy, corrosion, and material synthesis. That's pretty good. This is my third event for the day, and I got through that. Right? I saw it coming. I almost stumbled. Right? He has been the principal investigator of more than 65 research projects funded by more than 20 companies, the Department of Defense, Department of Energy, Office of Naval Research, and the National Science Foundation. He has authored or co-authored more than 265 publications. He has been a paid consultant for 40 organizations. He received a BS degree in metallurgical engineering, an MS degree in chemical engineering, and a PhD in metallurgical engineering from the University of Utah. You got all those at the University of Utah.
That's right.
You lead red for us, all right. He also worked as a postdoctoral associate at the University of Florida in material science and engineering and chemical engineering. Our second wonderful speaker for tonight is Saskia Divison. Saskia is the Chief Advisor Research and Development for the Rio Tinto Copper Product Group and manages the portfolio of innovation projects across the entire value stream, including ore body knowledge, underground and surface mining, mineral processing and metallurgy, tailings, and digital projects. Saskia has over 20 years of experience in operational, technical, and leadership roles based in Nevada, California, and Utah for a range of commodities, including copper, gold, silver, borates, molybdenum, and other critical minerals. Prior to her career in mining, Saskia was an assistant professor at the University of Utah's Department of Metallurgical Engineering. Saskia has a PhD in extractive metallurgy and mineral processing and a Master's of Science in Minerals Engineering from the University of California, Berkeley. She holds 4 patents in the area of process development and machine learning. She has a Bachelor of Science in Material Science and Engineering from the Massachusetts Institute of Technology, MIT. She's also a senior Rio Tinto expert. Please join me in welcoming both Mike and Saskia. And both of these two are so well known that whenever you do anything in this space, you often hear, you should go talk to Saskia. You should go talk to Mike. Have you talked to Mike? Have you talked to Saskia? And tonight you get to talk to both. So you'll say, I have talked to them, right? And they approve of my idea. That will be a clutch thing. I also want to thank our sponsors for tonight because we can't do events like this without sponsors. And our sponsors are Ballard Spar, Barclay Damon, Michael Best, Thorpe Northwestern, and Workman Nidegard. So thank you to all of our sponsors for tonight. And give them a round of applause. Thank you. If we do this right, it'll be a casual conversation. It'll start off formal, but then it'll transition to your questions. So first question for both of you, right? How does academic industrial collaboration help your organization?
Sure, I'm happy to start. It's kind of fun to actually be standing up here because what some people may not know if you were paying attention, Mike and I started a long time ago actually in the faculty together. And so it's kind of fun to see that he stayed on the academic side and I started there, have gone out into industry and now am back here and working. And I guess that's one of the things that I think is a great example of why it's so important in this work that we do from an academic perspective and an industry perspective, because it takes both. and there's multiple pathways to get there. And so I think this is why this kind of work really benefits both of our organizations, right? We can't, from an industry perspective, move forward without all of the metallurgists, the mineral processing, the mechanical, the electrical. Everybody is a key part of what we're looking for, but that starts then from the academic side. And so again, I think there's a natural symbiosis of the two groups working together. And so this is why we really do like to partner with universities, why we love here in particular from Kennecott to partner with the University of Utah, because it's part of our local ecosystem.
Yeah, and then I'll add that I think, when I do research projects, for me, I like to try to get industry involved in as much of it as I can, because I think it helps to keep it in focus on what's more relevant for the real world. And it's hard to do sometimes because the federal funding agencies and the kind of things that they ask for sometimes don't align really well with that. But in recent years, and in connection with the critical minerals kinds of areas right now, I've been leading a few projects in this area, and the requirement is usually to have some kind of industrial partnering. So I think, but that's a great thing. I think that's a really necessary thing. But I also think it's really important to look at this pipeline development too of the young people who are coming in to get degrees, to get training, and over the years that for us has involved students straight out of high school coming in and working in labs in some cases, getting some experience, getting the education that ties in with that, and then a lot of them will launch out into the industry and have a good base for what they're going to be doing in the real world. So I think it's really good to have that connection and have over the years we've had quite a few projects with Rio Tinto. We may talk about that in a little bit, but that's been very good on both sides, both from the workforce development that helps on that end to supply the people that are needed in the industry. It helps to develop some new technologies in some cases, and it helps to understand some problems out there that need some academic support.
So we're at a key pivot point in the federal funding landscape. If some of you don't know that, the last couple of weeks have been a little different from a federal funding standpoint. It's a combat sport. But one of the things we're hearing right now from the federal funders is they would like to see increased industry-university partnerships, deep partnerships that build ecosystems. And I think this is a great example of a space where we do that sort of work, right? And so you've already talked about this, but can you talk about a concrete example of a successful interaction that you had, say, between University of Utah and Rio Tinto?
Yeah, I can maybe talk about two different things. So personally, I've done quite a few projects for Rio Tinto out of their electro refinery. And so in these projects, there's been a sequence of smaller ones and then bigger ones, and we've had a few cases where we've had, in one case in particular, we had probably about 5 years of reasonable funding just to fund one student. But that allowed us to kind of look a little bit deeper into what was happening in some parts of the refinery and actually understand, in their case, they're trying to refine it and get the purity levels up. And so we were able to come in and actually look backwards at the process and go figure out from the previous processing step what was causing some of the things downstream and understand some of those fundamentals that were part of that. So that gave some tools to Rio Tinto to look upstream and say, okay, if we do this up here, that will help us down here in the downstream end of it. And then one other example I think that's really important, that's a really big win for the university and the industry. It's not a Rio Tinto project, and it's not my project, but Professor Fong in our department recently had Hyperion X sign a $10 million contract with his group to do a bunch of research in the area of titanium manufacturing, 3D printing, and titanium processing that came out of some research that was funded actually through different agencies, pretty much all DOE, but through ARPA-E and through just some regular DOE grants that helped that technology to evolve to the point where that company was able to come in and say, hey, there's a lot of value here, and put up $10 million. They helped us build an additive manufacturing center down in one of the buildings here, just down a little bit from us. So I think those are a couple of really good cases in point in terms of what you're looking at for that collaboration that's really beneficial.
So I think maybe I might speak a little more generally. I mean, even though I work in R&D, I actually don't even have a lab. I literally, people, when I say I work in R&D, people think I'm walking around in a lab coat. And I don't have a lab. So I have to partner with universities to be able to get access to some of those facilities, right? So that becomes a key part of some of the partnerships that we've had of providing us access to equipment, knowledge that we don't have within our groups, right? And I think what's been the most successful kinds of projects is where we kind of start small. And we start small, we start to explore an idea, just like you were saying, right? And that idea, sometimes, as we all know, R&D doesn't always go the way we expect it. Often it's from the learnings. I don't like to use the F word, the failure word. It's those learnings that actually lead us to that next piece, right? And that becomes something that builds and builds. And I think those have been kind of those successful partnerships. Because let's be realistic, the timeline typically for the academic type partners, work is going to be a couple of years. Usually in industry, we're trying to solve problems a little faster than a couple of years. Otherwise, I don't get to keep my job. So I think there's a piece of really thinking about how do you tailor those types of engagements, right? Some of our engagements are great for long-term, longer-term technology development, solving kind of the immediate problems. Occasionally, we find an opportunity to do that, and sometimes we look in different ways. But I think that's one of the key things, is really being agile in the way that we think about partnerships. The one thing I've learned in all the years I've been doing R&D is it is not one size fits all. There's not a single way of doing it. That's actually the whole principle of R&D, right? Is being open-minded and thinking differently. And I think as we've kind of shifted how we think about the partnerships, that it's not a one size fits all, is why we've really been starting to see some more success in the partnerships between industry and academic and the key partner, the government, right? And I think that's part of the shift that we're starting to see to come out, is to think differently about R&D as a true ecosystem. It isn't just a single group or a single partnership, which doesn't make it easy, but it sure makes it interesting.
That's right. So a couple more questions, and then I hope you're thinking about what your questions are going to be, because I'm about to start bothering all of you with what your questions are. Okay. Mike, how did you initiate your early interaction with industry? So how did you get started? Because we have faculty in here and we have researchers in here who are saying, this is great, but how do you start? Well, I see you at the end of this, or I see you deep into it, right? But how do I actually get going with this?
Well, I think that the real answer is you just start talking to lots of people, right? I think part of it is you need to get out there and network and find industry people, talk to industry people. And I think really a key part of it too is all of the industry collaborations that I've done over the years. When I meet with people, what I ask is, what do you need? What are your needs? What would you really like to see? Where are the areas where there's a need that an industry-university partnership would work? I mean, obviously they're not going to work with the university if there's some intellectual property things that they already have that are tricky to work around, or they know that you're going to publish things, so it's not going to be something that's pre-competitive kinds of things where they think they have an advantage. They're not going to share things and have you work with things and publish it. So I think part of it is you have to talk to, my philosophy was always find out what their needs are that fit the realm of what a university can do. And then I also think you have to be willing to work with them on at the level that they're interested in. Part of it is, as Saskia said, you need to kind of start small in a way, right? You kind of need to show them that you can perform, accomplish something meaningful with a small amount of money first, and solve or at least learn some things that are important and relevant, and then work your way up. And what I've found over the years is generally, if you keep doing things that they need and try and meet their needs, that funding source will often continue for quite a while. Until sometimes you solve a certain problem and then look for other problems. But I think part of it is just being open to how you approach it, also from the privacy protection end of it, where there may be some pieces of it where you can negotiate to not be publishing a certain part of it, you need to get students' theses and publications and stuff. So there's sort of a kind of a dual track thing. I think that there's some things that you can do on the side that are things that you can maybe not worry about publishing, for putting in a thesis, but be helpful to the company, and then have a core area that keeps moving forward with the students being able to publish it and put it in their thesis.
One more question, and I'll open up the floor. Saskia, what are the common mistakes academics make when approaching industrial collaborators?
I don't want to, like, it sounds negative, right? So I don't want to, because again, I think what Mike said is it's really key. That's one of the challenges with an R&D. You have to kind of persevere and keep knocking on doors, right? So we want to hear the ideas, but I think sometimes when it gets presented as a very big, large-scale piece of work, right? That becomes really challenging for us from timelines, right? Sometimes what we need to focus on changes, right? And so being able to keep that at a smaller scale or thinking about something, as Mike said, that's really relevant, I think is a really key thing for us. Interestingly, we actually like to talk to people sooner rather than later, whether it's academics, whether it's startups, whether it's OEMs, someone that has an idea in their garage, because trust me, we work with those too. And so the sooner that we can get talking with people, the better we have a chance to influence, right? Because sometimes people come to us and are trying to say, oh my gosh, we have the absolute best hammer for you. And I'm like, yeah, I actually have a Phillips screw, a bolt, I'm trying to, I don't know, a roof that needs tiling. And so again, but you're coming to me with a hammer. And so I can't do much with that. But sometimes people will continue to say and sell that they've got the best hammer and don't always listen that I don't need a hammer. And so some of that back and forth, like Mike was saying, of being able to say, what's my real problem and how can we actually shift or adjust to what I know you're really focused on it. You've invented something that's absolutely amazing. Probably will maybe not make you $1 billion in IP, so maybe be a little open to thinking about how do you negotiate the IP. And I actually will give big kudos to the U. I know when I started, and I was on both sides, IP journey was quite different than it is now. And so absolutely, I've seen this change in the academic world over the last few years. I used to dread thinking about IP negotiations with university contracts. Now I don't mind so much. I still get a little bit worried, but usually we can work our way through it. And I think that's one of the key things. It's this mindset to say, are you trying to sell something that's a new idea, or are you trying to manufacture something, right? We don't want to become the manufacturer of some new, amazing technology. We're a mining company. So thinking about then who might be the partners that you need to bring into that, because sometimes actually the mining company isn't the partner. It might actually be an equipment manufacturer or someone else. But can we actually make that as a full approach? And so I think that's the one other thing for university folks to think about, is what I like to say, systems thinking, right? It may be great to come to me with this amazing new idea, but we all know there aren't that many mines being built at the moment. So how do you want me to trial this new technology for a mine? I can't. So how can we trial it in a brownfield? How might we be able to expand it? How do we actually develop it? That systems thinking of, I have this technology, but how am I actually going to integrate it with an actual system? Because listen, we don't get value from R&D from the R part, we get value from the D part. And so really thinking about that aspect when you're coming up with an idea. I'm all for blue sky thinking, but occasionally a little bit of, toe has to touch the ground to make sure that we're moving forward. So I think it's that balanced view that becomes really key.
Awesome.